Hasita, Tushant, and Umesh. Only three of you and myself, only four, are in the classroom. Can you hear what I'm talking?
Yes.
Okay, very good.
Yes, sir.
Very good. Yeah. I hope you have downloaded the text I sent about the thermodynamics today.
Yes,
Yes, sir, we have.
Very good, very good. Yeah, keep the mics open. Yeah, that is okay. Yeah. So actually, I make your life easier by sending this note. Okay. So I will not ask any question out of this. Okay. I will not ask
Okay.
any question out of this. So you consider this as your Bible for your thermodynamics, the subject module, and also for the exams. Yeah. Don't worry about the exams also, because I'm testing not your difficulties but to strengthen your knowledge and understanding. That's all. So don't worry about the exam. Yeah. Just understand this. Yeah. That's it. Also don't go and memorize, because thermodynamics is a very beautiful practical subject. Practical subject. And this is real. And this is real. So real subject. If your knowledge is just a memory only, there is a gap between the knowledge what you are assuming and the knowledge what's supposed to be real. That's why the understanding of the subject is extremely important. Once you understand, you can throw away the memory, because there is nothing to memorize. All will be in the mind, and whenever time comes, yeah, things will come. Somehow things will appear in your mind. So learning should be in that way, not about memorizing. Don't give priority for memorizing and doing so much of maths, analysis, equation, but those all came after thermodynamics. Thermodynamics is really the nature. Okay, you know nature. There are four elements. We call the earth, water, wind, and fire. So in Sinhala we call this Patavi. Patavi means earth. Water means apo, the nature of the flowing. Yeah. And then the wind means vayu. That is something like expanding and contracting. So that is what we call vayu. And tejo means the hot and cold. Yeah. This is quite simple. So you have to start from these four elements when it comes to thermodynamics. Yeah. So these qualities of matter and energy somehow being changed in the application of thermodynamics. Somehow those four are being manipulated and combinedly working as thermodynamics. And other than these four elements, the space is very important. Space. That's why I gave you one very nice assignment of how seeing the space. Because space you cannot see by your naked eye. Space you have to use your mind to see the space, or the brain, whatever. Yeah, that's right. So the space together with the four elements, that is the thermodynamics. Thermodynamics. Yeah, that is thermodynamics. Even in engine, you see the piston cylinder engine, let's say example. Yeah. So there is a space for piston to move. And within the piston cylinder space, somehow these four elements, earth, matter, let's say earth means you will feel some solidity. That's why the piston can, during the power stroke, piston can drive this metal pieces, gearbox, differentials, whatever, and it really provides power. That is the solidity in that combination. So that is what we call the Patavi nature, the solid nature. Okay, and there is a flow somehow. Yeah. In the strokes, you can see flow. That is, we call the flow ability, the flow nature, apo nature. Okay, and you see the expansion and contraction, suction, compression. That is, we call the nature of the wind. Even when we breathe, yeah, if you feel your breath, you see the upper abdomen, you can see the expansion and contraction. That's the nature of this wind element. So in we call it vayu, that's a quality somehow. And of course the heat is there. The combustion is there, high temperatures, low temperatures, heat transfers, cooling, heating, all are involved in this ICE engine or whatever, even external engines, external combustion, whatever. So you can see the how important to see thermodynamics naturally. If you feel thermodynamics complicated and if it is not that so natural to you, not natural for you, you have to explore yourself how to see thermodynamics in natural way. Put understand? Can you hear me? Hello? Can you hear me? Okay.
Can hear you.
Okay, very good. That's why. So this is my first lesson today. Yeah, you have to be very relaxed. You should open up your eyes and the minds to the nature and see the thermodynamics in nature. And we are simulating those things physically here by ourselves, and we call it somehow we recognize this as a subject area. What do you call thermodynamics? That's why. So you are totally your thinking should be different, especially when it comes to technology. Even let's say like the Ferrari, Ferrari, uh, it's a very famous vehicle maker, the racing cars and all the high performing cars. Do you think they have this all the modern simulations and everything? Yes, they may have, but their experience matters. Experience. Those things are not in the books, not in the computers. Put understand? Of course, they do the experiments, test all, but the initiation of these tests, the experiments, ideas are from the human beings who have a very good sense of uh, the natural thermodynamics. That's why. Yeah, even the Toyota, the very efficient engines. Why nobody can copy it? Yeah, of course. In appearance, you will see the technologies, what you can see physically, but when it comes to the real performance, there are something hidden. Hidden means, of course, it is hidden because those who see naturally, that cannot be seen by the others. If they see naturally, somehow it's better, they will find the better solutions. That's why. So thermodynamics is something like that when it comes to the subject. Yeah. Even nowadays, modern applications, you can see the appliances when it comes to appliances. Also coming at thermodynamics, example, your refrigerator. See how it is upgrading, day by day, year by year. Even in the computers, there are CPUs and lot of heat is generating there. So the cooling system, very effective cooling systems are there for CPU cooling. No matter heat pipes or technologies, yeah, because the generating energy we have to this thermal energy should be moved out from the computer, the CPUs, even in your laptops. Yeah, so that's why. So there, the thermodynamics still being explored. Even rocket science. Yeah. the propulsions, whatever the turbines, the aeroplane engines, air conditioning, even the heating, industrial, lot of applications, boilers, furnace, then burners, incineration, air conditioning, process heating, process cooling, energy recovery, recycling, heat transfers, pollution controls, wherever you will see this thermal aspects and thermal applications. So nowadays in modern day thermodynamics, all are included. In earlier days, thermodynamics may only refer to some engines, but now thermodynamics and heat transfer is quite broad scope. You cannot limit just for the power generation using the thermal energy. That may be the thermodynamics. Dynamics means the moving. Thermo means thermal energy or the heat. Movements caused by heat may be the earlier what they interested. So, but this thermodynamics, the name appears and this put for the scope of applications. But now thermodynamics is quite vast. Yeah. Even in the human body, yeah, if you really see the body, there are a lot of thermodynamics aspects there. Even in the plants, you will see. But understand this thermodynamics is something quite challenging. But anyway, humans do understand this, including you and me, up to certain extents, if we are interested really. Yeah. So somehow you can see even this power generations, thermal power generation, all included the thermodynamics. So please recognize the importance of the subject. This is, I would say, the mother of all the subjects, because if you know thermodynamics very well, not just the paper knowledge you to solve some equations, but the real sense of the real sense of the applications and how you can recognize the thermodynamics phenomena happening in the nature, you will be very successful in your technology field. You can do plenty of things. Even in the kitchen, your rice cooker, your burner, even your blenders, also they generate heating. Your ovens, microwaves, refrigerators. So even some designing of the pans, or some cooking utensils, even design of a spoon. The thermodynamics and heat transfer is there. That's why. Yeah. Even when you design a motor, electric motor, the heat dissipation, how to minimize those, how to control those. If the heat is generated, how to get this effectively dissipate. Everything, everything thermodynamics. Even now the LED bulbs, there are heat sinks, wonderful thermodynamics designs. LED is one of the very important technologies are the heat transfers, how to cool the energy generation. It really improves the performance and also the lifetime of that. Yeah. So even in the packaging of the electronics, yeah, thermodynamics are there. Everywhere you will see thermodynamics in all the fields. So please appreciate this subject. Yeah, you. It is a must to recognize this subject. It's a must to have. It's a must to have a natural understanding of this subject. That is very important. We naturally try to understand this. At the same time, we will get the book knowledge also for some analytical point of view. Okay, for some analytical point of view. Putal, understand? Can you hear what I'm explaining? I hope you can understand. Can you hear me, Putal?
Yes,
Hello?
sir.
Very
I can
good.
hear
Yes, sir.
you.
Very good.
Yes.
Yeah. Yeah. So that's why. So when I see this, the opportunity you are having with this subject, that's the reason I give you the very important assignments. One about the space, how to see the space in your designs. Even the architects, of course, what they are doing, they are managing the spaces. Even what's a window? It's a space, it's a gap. What's a dome? It's a gap. maybe for air to flow or wind to flow and the sunlight to come, people to move. Yeah, you can see even designing of a chair. It's a matter of crafting a specific space, designing of a room, whatever the tables, anything. Even a rice cooker design. What is rice cooker? Of course, heating elements and all external cover is there, but inside it's a pan to put the rice. It is really empty, but it is performing when you put the rice and water and when you insert in the cooker and when you plug in, it is performing. It's boiling rice. The rice being cooked inside. So, if you have a good sense of thermodynamics, you can do a very nice rice cooker. That's why. Just examples. Yeah. Heaters, whatever, even the kitchen utensils. So you must have this sense. Then only you will be innovative because you have to be a very good observer in looking at the things with the thermodynamics eye and thermodynamic sense. That's why. So let me share one more thing with you. Yeah. So air, we know the air. It can, of course, it has a flowability. The water quality is there with the air. Other than that, it expands, it suctions, expanding, and the volume increase, volume decrease. That is the quality of the air. But when you pump this air into a tire, can you imagine? It is solid. Air quality is quite less, but air quality is there because it is bumpy. When it's gone irregular tracks and on the humps to absorb something, the impacts, absorbing the impacts, first done by the tire. There only the air quality appears. Otherwise, all the while tire is solid. See, even water can be used to cut high density material, even like metal. You can use water to cut metals. How come? That's why. So the same water when you pressurize and if you make it is a very thin sheet or a flow, very thin, high pressurized. The solidity is there, the sharpness is there. No more water quality is there. That's why you can see the natures, the wonderful nature. Yeah, you should understand this. Even when you put water into a glass, let's say the drinking glass, if you put water, yeah, the flow ability is no more there and it has a certain solidity. If you manage to punch the water in the glass, the glass breaks. Why? There is a certain solidity in the water when it's in the glass. Flow ability is no more there. The water is stuck. You understand? තේරෙනවද කියන්නේ? Huh?
Yes, sir.
Yeah. Can you understand it? But then, so what I'm talking now, no equations, even no thermodynamics word. Yeah. This is how we can say. This is how we can say thermodynamics. To understand? Yeah, that's why. So you have to open up your minds. You have to open up your eyes. Okay? And you have to get a real good knowledge beyond the words. වචනවලට එහා යන දැනුමක්. දැනුමක් දැක්මක්. You have to see the thermodynamics. Yeah, you have to see the thermodynamics. You have to feel the thermodynamics. That is very important. And that is something very special I'm sharing with you other than sharing the textbook knowledge. Understand? So make use of my experience. And the way I am sharing with you, it is very rare having this kind of sharing people. So get the maximum out of this sharing and these discussions. That is extremely important, Bhutala. Yeah, we have to bring the thermodynamic subjects to life, to perform in front of us. That is extremely important. Don't leave thermodynamics in books. Then the subject is dead. Okay, if the subject is dead, yeah, how we can contribute, how we can perform. That's why. So this is a very important subject to learn. This won't be a waste. That is not possible. If you really learn thermodynamics in very effective way, you cannot keep it in hiding. Ideas will come, innovations will come. You will do many things because that is unstoppable if you really understand the subject, if you really see the subject, if you really feel the subjects. You cannot keep it in hiding. That is not possible. You will be great inventors, innovators, creators with ideas. You can move forward. And that is what we need for Sri Lanka even today. That's why. Understand? Yeah. But somehow we need to face the exams. So this helps. But in my exams, it's a blend of practical means good sense of thermodynamics and little bit of theoretical aspects. So you as the weekend students, you have very good experience, you have diplomas, certificates, you are really on these fields, most of you. So this sharing of these ideas and learning thermodynamics with me definitely will bring a very good benefits for you. Yeah, I'm sure of that. So please, so this is today the very first discussion. Yeah. So you have to believe me. Yeah. And also you have to believe yourself. Yeah. Bring this subject live within you. So that should be your focus and interest of learning this. Of course, but you have to learn some theories as well. But believe me, Puta, just a book knowledge will not make you somebody. Yeah, that is the sad part of this this book learning culture. So we have to now the many countries they already moved out from this book learning culture. So we have to talk, we have to share the experience, we have to open our eyes to the applications, to the world, and we have to be innovative. Those are not in the books. Sad to say, but no choice. We will learn and get enriched from the book knowledge, as well as we will try to gain the real practical sense, and we will take something out of the books, and we will be out of the box as well. I hope Uta, you can understand. Yeah. So that's all. Having that in mind, I gave you the previous assignments. But before that, let me look into the text I gave to you. That's why I told that I no need to test your book knowledge. So you just understand this. That is good enough for your exam. Okay. So you have to do this as well. So there is a revision topic. Just try to understand this revision topic. Then about the non-flow processes, you will understand. Even you have to understand each and every word, sentences, and you have to go beyond this. Non-flow processes, and then the steady flow processes. Yeah, see what are these. Yeah. And then the second law of thermodynamics, vapor power cycles, and then 6 and 7 you can avoid 6 and 7. Actually, you can. It is very nice to learn these things because these are practical. Heat transfer and fluid flows and more. If you are interested, heat exchanges are there. 6, 7, 8. Up to you to go through as a self learning, but I will not be asking uh, anything from 6, 7, and 8. So this chapter 1 to 5, everything is there. You understand? Yeah. And the other point is, actually, I'm not going to go through this in the class because I leave it to you. So I will use some other sources to bring this same lesson out of the book. Yeah. So you try to understand this. Lesson 1, 2, starting the revision. 1, 2, 3, steady flow. The third one, fourth one, second law. Very important, and the power cycles. That's it. Okay, that is your book knowledge. Okay, how many pages? 56 pages. Nothing. Nothing. You can do it in 1 2 weeks. You can do it in 1 2 weeks. So try to get this. To understand? They're going to give it.
Yes, sir.
Good, good, very good. Yeah. So, yeah, part one. Okay. Mass and energy balance. That is the revision, and also the non-flow processes and steady flow processes. So what you are doing is just to deal with this mass and energy balance of systems. You know what mass means, you know what energy means, you know what mass and energy balance means, and you should know what system means. Yeah. So that's why you have to be very mindful and try to see a little depth of this, a little deeper sense of these topics. It is very important. So this is that. So once you understand this, you will learn this. That's all. Okay. So this is the revision, but this is very important. Yeah. This is a nice definition. Okay. It's a nice definition. Do you see this screen? Yeah. Thermodynamics is a branch of science and engineering tool, yeah, used to describe processes that involve changes in temperature, transformation of energy, and the relationship between heat and work. No matter. Yeah. See the thermodynamics, heat and power. The same thing I mentioned earlier. Yeah. That is earlier days, but today the same name is probably broadly interpreted to include all aspects of energy and energy transformations. That's why now the scope is quite broad, even though we are using the same word thermodynamics. This is much more than heat and power. Yeah. Uh, that's it. So we will try to feel this. Don't try to memorize this. Yeah. Then when it comes to the thermodynamic systems, yeah, thermodynamic system. So you can see you can go through this. That is one thing. Okay. So here are some examples. So in the system, you will see these three terms. The word system itself. System has a boundary and the surrounding. System has a boundary. Out of the boundary is the surrounding. Okay. That's how it is. So let me take a very simple example. Very simple, or even this one is okay. This one is okay. You can see here the gas 2 kilograms. Initially 1 meter cube, yeah, 2 kg 1 meter cube. So when you heat it, what happens? It moves up. Your matter of interest are within this, excluding the voice and the piston. So naturally you will recognize the boundary. Within the boundary is we call system. Anyway, here a lot of molecules and all. So we call this system. It's okay to call this as a system. Even though you feel this a single entity, we use the word system. Okay, system. So see after heating, change. So your system boundary moves, but still you will see the boundary. Okay. So within the boundaries your system. This is the system boundary. Out of the system boundary is the surrounding. To understand?
Yes.
Understand? Good, good. Likewise, try to understand this, and of course, there is a volume in the system, so we call this somehow in the open systems here. There is a volume here, the volume changing, but here you can see sometimes maybe like in a small boiler, maybe tea making boiler, whatever, you can see some ins and outs. So then what happens is our interest is here in this case and this volume. So water comes to this space and water moves out of the space. So this space is our interest. And we call this space is of course it's a 3D, the volume is there. So we call this control volume. And things are moving in and out. Yeah, that's why. Yeah, control volume. So every keywords here you can see highlighted in bold. So open means metals can flow through the system. Then we call it control volume. See the space word I have used. Yeah, that's why. So you need to exactly follow the same sentences, but the space, the keyword is there. It's a region in space. Also selected specific space. So masses, matters coming, matters moving together with energy, energy also coming with matters and moving out. And that certain space is there. So that may be the interest for the system, what you call the open system. And here those are the closed systems. So you can see closed system here. So this takes the importance is everything you can get in one shot, in one document. Okay. So this is very nice. Yeah. Then you will come to the properties of the system. Don't memorize. I hope you understand how the V appears from the space. Okay. Then the matter, we talk about this. And of course, temperature and pressure comes. So the basics, uh, the pressure comes from the force, temperatures, volumes, masses. So these are the physical properties. We call it physical properties. So these properties. So experimentally, if we can have the values, the combination of these values explain the condition of that system or the matter at that time. That's why we call them, those are the properties of that system or the characteristics of the system. Yeah, is explained by property. Yeah, okay, is explained by property, not just one property. So you have to go through this. You have to go through this. You have to go through this and see the basic properties. Mass, of course, from starting from your primaries, you know the mass, volume, temperature, pressure, and density. Even in my second assignment, you have noticed these things. But still, that is very important to feel, you know. If you don't feel the space, the matter within, the extent of the space, that is the volume and the temperature, pressure, density, if you don't have the feelings of this, your thermodynamics understanding is out. And this should bring out from your memories and try to have a very simple understanding like 1 times 1. 1 into 1 is 1. Yeah. You need to memorize. 2 into 2 is 2. Naturally comes. Same way you should have a natural sense of that. So Putta, I have a simple request to you. So in because this is a free Zoom and in 5 minutes time, this is going to be over. So please be patient for another 30 minutes. I'm going to open up a new slides for you, but this one is for you to go through. Okay. Let's say example, can you see the cursor? This can be a tire. Okay, this can be a tire. Oh, this can be a gas cylinder. Yeah, that's why. So don't see this letters inside the box. Don't don't see in that tree. Understand? Yeah. Don't see in that tree. These are the letters inside the box system. That is not the rules and the lines on the paper. Okay. That's why your imagination is very important for the subject. So you this system, you make it half or even tire, you can see two portions of the gas cylinder. Yeah, if the purely it is gas, you can see the temperature, pressure, and density is common. Mass halves, volumes half, of course. So extensive means this depend on the extent or the size of the space. Then we call this extensive properties. Others, it depends on the intents, not on the extents. Yeah, extents, intents. The, the, not to say opposite, but you can see the contrast there. So temperature is an intensive property. Pressure is intensive. Everywhere pressure is pressure. Everywhere, no matter tire, wherever you get puncture, the air comes out at high pressure. Sorry, high velocities. Yeah. So same densities, same pressure, same temperatures, but the mass becomes half, volume becomes half. So try to understand that too in very practical ways. How to see the extensive and the intensive properties. And in most cases, we can analyze using intensive properties and also we can analyze using extensive properties. So density is the mass per volume. Mass divided by volume means for unit volume, what kind of kilograms, the grammage. The other way, for a given 1 unit of kg or grammage, the volume, we call it the specific volume, then it is intensive property. Later we are going to discuss this in our second session. Right now, because our time is now only 2 minutes, you can see the screen maybe in 2 minutes. This session will be over, so let me continue this with one more session. So hopefully we can restart again because this is going to be recorded. So this is recorded, so this is going to save after 30 minutes or 40 minutes. Then we can restart the Zoom. So give me few minutes to come back. Okay. Yeah. So till then, we will go back to the beginning of the discussion. Because remember, this is damn important subject. Damn important subject. Yeah. Don't don't think to neglect this. That is very bad for you. Yeah. Try to appreciate the subject. Try to learn. Learning is very easy. This one. Yeah. Learning is quite easy. This subject. We don't need to learn everything. Everything learning is impossible. We don't know actually this subject. Our knowledge is limited. That is all right. Nobody knows everything. Nobody is perfect. Not knowing is okay, but the important is to get something out of this and make it real for us, for the betterment, for the society and also for us. Okay, Putana. Very good. So the last minute is gone. So let's continue this chat for this 1 minute. After that, this will stop and will save the recording. Then I will come back to you in 5 minutes time with the new slides. What have to be added here? We will discuss and we will see how important those. So that is only what I plan for today. So anytime this will stop. Don't worry, till then we will talk. Anytime this will stop. Yeah. So you go through this. No matter this PVRT all you know, but still go through this. It is very